Okay, so today we are going to be discussing the LCD connections for the PIC Trainer board. So the first thing that we have to do is we have to look at the spec sheet for this trainer board. And we see that pins 1 through 8 on this board are the data lines. So that's the first connection that I like to make. Why? Because it's pretty simple. Before I get to doing that, let's do our standard resonator connections on the PIC 84A. So our standard resonator connections are like this. Alright, now, if you notice pin 1 is way down here, so let's get a color. And just because these first 8 are equal to 1 byte, I like to put it all on port B because there's 8 pins and 8 data lines, so it makes sense. So this would be 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. You get the idea with these. Let me change this slightly different color. And this click is annoying. Alright, so slightly different color. So that way you can see me just kind of cutting through everything. And now if we count, this should be right around, this should be exactly 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, we got all the pins. Alright. Now, the next one, let's start with V0 or VO and RW. Yeah, okay. So, V0 is the contrast, and RW is the read-write switch, and to make those 0 would make maximum contrast, and always put it on write mode. Now, because we're not going to be reading from the registers there, we're going to do that. So, let me move this one and this one. Now I can tie these together, and then let's go over here. And then you'll see that this pin, either this pin or the next pin over is the grounding pin, but either one, you might want to make sure with the voltmeter, just put the red connection on ones. And I know that definitely that they're separated like a plus and a minus, a plus and a minus. Which one's the plus, which one's the minus, I don't know exactly. Just do some little experimentation, I guess. Okay, and then we have 2 more pins left, R, S, and E. Okay, so we'll do these 2 individually. Here we go, here's a nice color. So, RS is pin 9, so we'll start here. Now what RS allows you to do is select whether you're sending a command or a data byte. So I'm going to move it to port A. It doesn't really matter where you move it, just as long as you know how to program it. Now the enable is required for the toggling. So for the enable, I'll show you in a little bit, but we're going to need that falling edge to latch data values in or command values. And so we need to have it over here too, on port A. Now this is your basic setup. It's going to look a little messy in wires unless you're very careful. So be very careful. And your LCD will actually plug in right here. You'll see this little notch right here. And there's a secondary one right over here. These will make sure that you insert the connector correctly. You're not going to mess that up if it's been corrected correctly prior to being shipped. So you just insert it and it'll work right away. Now another interesting, the enable pin first. So if we have our enable pin, Oh, that's a little big. Alright, so if we have our enable, we can have it doing this type of deal. Now on these falling edges is where we're going to latch the values, of course. If you looked at the previous video, you'll see that it's actually that way. So if we have our data or command, it doesn't matter, it all comes over the same line. So we're going to have this going on where you don't know exactly where it is, and you're just going to have these X. And so when this falling edge occurs, whatever value is right there gets latched in, and it does the appropriate command. Alright, so then the final thing that I really wanted to discuss was macros, because macros will make your life easier. So basically you can have your subroutine, and it has some values, and it has a return statement, however your processor implements the return. So now on the PIC 16F, what you can do is you can make macros. Actually, in any language you can make a macro, any programming language. So what the PIC 16 macro function call is you have your value, so we'll call it, or your macro name, so we'll call it command byte. Alright, and then we have macro, and we have the values that we want to send it. And then inside you can put some stuff, whatever you want it to do, and then you have to always follow with an end M. So we can view this right over here. I have the macro sleeping, macro number. I have some objects in here, and I end it. So we want to make a command byte. So we're going to say command byte macro value. Now we can use this almost as if we are pushing a value, so we can call our subroutine and we're going to have to move value. Alright, so what this basically does is now in our code we can go command byte and say we want to send the reset. All we have to do is send 0x30, and we can do the same thing, and 0x30, 0x30, and then whatever the other values are. But it abstracts it out, so that way when you're programming, you get these command byte or the data bytes commands working right, and you get it working once, and then from that point on, all you have to do is call this macro with the value, and it'll take care of the rest. Now you might be going, well, why is this such a great big deal? Because when you look at your code, you can either have these two lines, or you can have this line. Now if you look at these two lines, it's not very clear what's happening, but if you look at this line, it appears that you're sending the command x30 to the LCD, and in my code I actually have a data byte 2, and when I send the letter H, I send it like that. The macro takes care of it, and everything works out just fine. Uh-oh, something's not right.